Hi everybody, Dimitri's here. We had a few folks having issues with calibrating multi-camera and light stage type of rigs for facial capture. That could also be helpful for just multi-cam setups as well. What you see here is actually two cameras and light in the same plane. You would have a subject at the center. Imagine this a human head pointing this way. That's just a roll of regular leather that has very good representation of a human skin in terms of how it reacts to different polarization states. We have two cameras, both of them, both cameras have circular polarizers that actually have linear polarizers facing the light first and then circular facing the sensor. And we have linear polarizer on the light source. For the light source to track it, we have these vertical heat sink fins. So when we move it around, we'll make sure that that orientation stays the same, and so polarization on that light stays the same. So normally what you would do in this case, you want to have a setup so that all cross and parallel polarization states would all be consistent across multiple cameras and different view angles. So if we move, just right now rotate polarizer on this camera until that highlight is gone. Okay, that looks pretty good. Now let's move this light next to this camera. Keep the same orientation. Do the same trick here. Okay. Somewhere there. So it looks like it's good. But if we look at this camera, we would see that there is a highlight there. If now we take this light and still keep the same orientation as before, keep it vertical, see like there is no highlight there. So that's it. Good. But if we look at this camera, we see that there is a highlight there. And we go and start turning polarizer on that one again. And the problem is that we will keep doing that, and we won't be able to get perfect polarization this way. We'll just be going back and forth. And it will never be perfect for that specific topology there. And the problem is that even when you don't have polarizer on the camera, when polarized light, or any light for that matter, would hit that surface at an angle like that, it would get polarized, and that would have an effect. So to demonstrate that, now let's just take this filter of the camera. Let's put it over there, and let me see if camera can. So now I'm going to turn this filter on the light itself, and watch what happens. Come on, focus. It gets brighter, gets darker. Unfortunately, it's very hard to show it on camera. But what you would see is that at some point it will be very bright and it would get darker. So we still see the highlight, but at that point it got darker. And as you can see, we have filter on the light, but we don't have filter on the camera. And that polarization on that polarizer on that light source, when it interacts with surface at that angle, still has an effect. So right now we tuned it so that that highlight is minimized right there. So now what we want to do, we want to adjust this camera right there. So the same as before. Now let's take this filter and put it back on our camera. Let's grab this light, keep the same vertical orientation as for the other camera, and turn the filter on the camera until it's gone, right there. So you see now they're all in the same plane. We don't have highlight here. Let's check this other camera. Do we have a highlight? It's really hard to... Well, there's very little to no highlight at this angle. And right there seems to be good. And it's good there. Now let's move it back. Move the light so there is no highlight there, and there is practically no highlight here. Just if I move light a little bit, then it's gone. So there you go. So in this case we have like some residual stuff, but it's not as bad as before. So in this case, this is specifically optimized for that type of cylindrical topology, that or just orientation of the rig where cameras and light primarily placed kind of in the same plane. Come on, focus. But that's the trick, really. So we need to take into account that if you have polarized light, or even actually non-polarized, and interacts with the surface, we would get some polarization there. So before start tuning all our lights, we need to make sure that in the same plane the polarizer on the light is adjusted so that this camera that's at 90-degree angle has the least amount of speck in that area. And that would be our baseline orientation for the light filter. And then all the lights that go in this plane, we would want to make sure that they have the exact same orientation of the filter, so we can actually run the same process and for basically other polarizers, put a mark on it and make sure that they're all the same. So if we do that, then no matter where we move this light, when it's oriented the same way, like this, we won't have highlight there. Again, so and we have nothing there. The camera is clipping, so it looks like there is a highlight, but there is really little. Nothing there, nothing there, even though the light is kind of sort of halfway between the two. So that's about it. Just when you do this polarization, just need to make sure that you do everything with respect to the surface that's going to be the most representative of what you're scanning. In this case, I'm just talking about this is like a human head for facial scans, where you have head facing like this way, this camera. So I hope that helps.